UDLD, okay, do show UDLD gigabit 01 can show us UDLD is disabled again on this interface. Why? Because here we don't have any fiber link. Or if you use UDLD aggressive, again we have the same condition. Okay, UDLD doesn't work. Why? Because here we don't have any any fiber optic link. Okay, let me to configure UDLD in this scenario by interface based command. Interface gigabit 01. It is so easy. UDLD port. If you use UDLD port means I want to use UDLD in normal mode. But if you use UDLD port aggressive means I want to use UDLD in aggressive mode. That's it. UDLD port, for example, aggressive. Now UDLD is enabled on the port gigabit 01 of the switch 1. Let me to show you. Show, for example, UDLD, then in the gigabit 01 can show us that UDLD is enabled on this interface port. Enable administrative configuration setting. Enable means I have configured the UDLD on this interface. Port enable operational state is enabled in aggressive mode. It's okay. Current bidirectional state unknown. Why? Because we didn't enable UDLD on the other side. Okay, because of that we don't have any neighbor information. You know that we show UDLD neighbor, we can see our neighbor, but here we don't have any neighbor. It is so easy. Also, if you want, you can, for example, capture the link between the switch 1 and switch 2 for example, seeing the UDLD packets. After that, let me to configure the switch 2 also. In the switch 2, I'm going to configure interface again, a gigabit 02. Gigabit 01, okay, with the UDLD port aggressive. Now it is working. Let me to show you the captures. Here you can see the UDLD message. This is the UDLD message, for example. Here we have this information. The detail of UDLD is beyond the scope of our course, but here you can see the version. This is the UDLD echo, and here we have some information related to the, for example, UDLD. Let me to show you the result of the UDLD in the switch 1. Show UDLD first. Interface, okay, or gigabit 01 can show us now UDLD is working correctly because we can see the state is bidirectional and single neighbor detecting on other side of the link. Message interval is 15,000 millisecond. Actually, this means that this is equal to the 15 second. Okay, and also here you can see the information related to the neighbor. If you want, you can use show UDLD neighbor. Look at here on the gigabit 01 we have this device. Okay, device ID is 1, gigabit 01, and state is bidirectional. Also in the switch 2 we have similar information. Show UDLD neighbors, okay, and then show UDLD for example gigabit 01. As you can see, when we are enabling UDLD, okay, we can easily understand that this link, this fiber link, is working correctly or not. Don't forget, UDLD is not only for detecting the loops actually, okay, because we want to use UDLD for detecting unidirectional links. And also one of the benefits of the UDLD is preventing the loops in the spanning tree or in the for example layer 2 networks. Actually, UDLD is not a feature related to only a spanning tree protocol or STP. We are using UDLD for preventing unidirectional links working in our network, okay, for detecting unidirectional links. But one of the benefits that UDLD can give us is the for example preventing loops in the layer 2 networks. As I mentioned before, in UDLD we have two modes of operation. The first is normal. In normal mode, if a frame is not acknowledged, the link is considered undetermined and the port remains active. But when we are using the aggressive mode, in aggressive mode, when a frame is not acknowledged, the switch sends another 8 packets in 1 second interval. If those packets are not acknowledged, the port is placed into an error state. Also, let me to say that maybe in some iOS you have some other commands. For example, you know that we can enable UDLD globally with UDLD port. okay, or UDLD enable or UDLD aggressive, okay. Assume that we have configured UDLD enable, but we don't want to enable UDLD on one specific ports. Okay, for example, on the interface gigabit 02, I don't want to enable UDLD. Here we have a command UDLD port disable, okay. What does it mean? It means that we have enabled UDLD globally on all fiber links, but on the gigabit 02, I don't want to enable UDLD, okay? With this command, you can disable UDLD specifically on this interface, but as you can see, this iOS doesn't support it. Maybe your iOS support the UDLD. Also, you know that when one interface, because of UDLD aggressive, is going to the error disable state, with the UDLD reset command, we can enable that interface again. For example, assume that the gigabit 01 considered as unidirectional links, we have corrected the interface status. With the UDLD reset, you can enable the interface again, or if you want, you know that in the show error disable recovery, okay, we have some options here. For example, one of them related to the UDLD. You can enable the UDLD error disable recovery. You know that by default the timer interval is 300 seconds or 5 minutes. If you want, you can configure error disable recovery calls UDLD, okay, and after that error disable, okay, error disable recovery interval. For example, the lower value recovery interval 100 seconds. What does it mean? If we experience UDLD error disable interface after 100 seconds, this interface should be enabled. Again, show error disable recovery, okay, can show us that we have enabled the error disable recovery for the UDLD. It is possible. This is not related to UDLD. Actually, this is a feature related to the error disable recovery. Don't forget, UDLD and also the loop guard are working in one, for example, about one problem when we don't receive BPDU. But loop guard or STP loop guard is a feature related to STP. Okay, but UDLD is not a feature related only to STP. UDLD is a feature for detecting the unidirectional links. You know that fiber optic cables consist of strands of glass or plastic that transmit light. A cable typically consists of one strand for sending data and another strand for receiving data on one side. Okay. The other is directly opposite at the remote site. As I mentioned, as I showed you, network devices that use fiber for connectivity can encounter unidirectional traffic flows if one strand is broken. In such scenarios, the interface still allows a line protocol upstate. However, BPDUs are not able to be transmitted and the downstream switch eventually times out the existing root port and identifies a different port as the root port. Traffic is then received on the new root port and forwarded out the strand that is still working, thereby creating a forwarding loop. A couple solution can resolve this scenario: STP loop guard and unidirectional link detection. And now you have learned about both of them. But you know that loop guard is a feature related to STP, but UDLD is a feature related to other all of the functionality, all of the protocols that we have. Because when we have one unidirectional links, maybe many protocols cannot work correctly. All right, now let me to talk about the next feature, BPDU filter. You have used BPDU filter in the loop guard scenario, but I'm going to explain it. Actually, BPDU filter is a dangerous feature for our network. When you are configuring BPDU filter in the network that we don't need BPDU filter, maybe you encounter with the loop. You have experienced it. For example, here in this simple scenario, let me to show you what is happening. You know that the switch 1 as the root bridge should send BPDU, okay, to the, for example, switch 3, and also again from this interface gigabit 01, we are sending BPDU to the switch 2. And also finally, from the switch 2 in the designated port, we are sending BPDUs to the switch 3. You know that if we enable BPDU filter on this interface, for example, we will have loop, okay, BPDU filter.